Hello everyone. So this video is gonna be about the project I've been working on for about a month now. It's called Pythagoras, as you can see on the screen, and it's a library made in Python to generate SVG and TikZ figures. Well, programmatically instead of writing the SVG and TikZ code by yourself. Thing is that I'm a very lazy person. I have to admit that, and so instead of I'm not really proficient with neither of these two formats, so I end up looking stuff up many times. I don't. I waste a lot of time doing that, and I've always wished that there was a sort of way to generate all these figures. Also, that in a way that it can export to both formats at the same time, uh, using a better way than it is Tech and SVG. Because Tech, for example, I think it's Turing complete. I believe I'm not really sure about that, but still, it's not. It's not in practice. It's not really. Um, Useful isn't really comfortable. Language you're going to be very comfortable with doing writing code, right? So that's why most people would like to do Python instead. There's going to be a short introduction to how to use the package. And so without further ado, let's get started. Let's first look at the contents, what we're going to cover today. First, how to get the package, how to fetch it and install it. It's not, we're going to go over it very quickly. It's not a really hard thing to do. A lot of things that it's not on Python package index, so you'll have to download it yourself. It's one line in shell. Then first steps, what the most important aspects of the library, the most core fundamental things in it, how to get started, more or less how to understand it. It's not really complicated at the time because I made it, and so it cannot be really complicated. And then also first, so the first part we're gonna cover how to add figures, how to make shapes, I don't know, circles, polygons, etc. And next we're gonna cover how to style them because of course what you wanna do is put colors to it or fill it with some opacity, etc., etc. A good figure has to have some detail, right? So that's what styling. So that's the next section is gonna be about that. And finally, we're gonna end up. The last thing we're gonna cover is how to do some computation, some geometric tools that Pythagoras already provides for you. And so, well, there's another one that is it's not here because LaTeX. So, well, firstly, we're gonna get ready and are gonna install the package. It's not on PyPy as of right now. I don't like putting my stuff on PyPy or any index. I like keeping my code in a place where I can host and manage. It's kind of hypocritical because at the end of the day, it's on GitHub, which is well, it's burning right now. It's in a very bad situation as of now, but still, it's I don't like hosting in a registry. So well, that's not really a problem. You just do Python or pip install git plus and the URL, the canonical URL. As of now, again, it's on GitHub slash well my username and Pythagoras.git. But this will fetch. This will get the whatever's in the main branch right now. So you might not want to do that. It most likely you don't want to do that because it may be broken by the time you install it. So instead, you should git clone it and then look at the release and say, okay, git checkout dot version whatever the last version was. So in this case, the last stable version right now is 3.0, so 0.3.0, and then you just pip install it as you would do with any other package. Also, very important, this is mostly documented, so if you head over to my GitHub page slash Pythagoras, you will find all the documentation there automatically generated by Sphinx. I think I have not missed anything. Um, yeah, I think it's pretty much everything over there. So if you want to actually look at the docs, if you want to figure out something in particular, the best way to do it is over there. Of course, it's not the best way to learn because that's just a reference of what everything does. But you should first watch this video and learn how to get started. And then if you have any doubts, go to the reference in my GitHub page. I also, if you have it installed, just PyDoc, do Pythagoras or whatever module you want, and you can see the doc string, the documentation already formatted for you. Also, pull requests, and if you report any issue in pull requests, you're really welcome to do that. It will help me a lot, and I will go to it. Uh, anything, they're really welcome. So first steps. So how do we start with Pythagoras? Everything is happy object. That's just, if you are gonna take something for this, from this video is to take something. Is that every single object in Pythagoras, well, is a P object. P for Pythagoras object, right? It's essentially something that can be rendered, something that can be drawn on screen. That's what a P object is. And formally, in practice, well, actually, it's a instance of an abstract class called P object that is under the P object module, but that's not the matter for this. If you want to look at it, go for it. But yeah, it's a P object, and it's something that exposes a couple of methods within. The most important ones are object.svg and object.tix, so that you can compile to SVG and compile to tix. These are the I put as of now because maybe in the future we had, I don't know, PS tricks, for example, for PostScript, or a PDF, compiles to a PDF or raster for making a bitmap. But as of now, the only formats are SVG and TikZ, so it supports only these two commands. Anything that can be drawn to SVG or to TikZ, that's what a P object is. And so if you ever use manim, this is similar to an M object. M for manim, P for Pythagoras. And so everything, all the P objects are going to be contained in a canvas class. Canvas is going to look like the parent of all of them. It's going to hold them as a container, and then it's going to be in charge of rendering them in whatever order you specify. Again, you create a canvas instance. I'll show you right now. There will be snippets of code in this presentation. But that will be all. So give me a second so that I can explain this, and then you will see some pieces of code. We'll do a practice example in a second. So yeah, it's in a canvas instance, and at the end at the end, so you're gonna append your objects to the canvas, add them, and then at the end, when you have already done everything, and then you run CTX. Well, I call it CTX for canvas. You'll see me use that notation. So CTX is an instance of a canvas. At the end, you'll call CTX.svg or text. So that will give you a string with the SVG code or the TikZ code. So yeah, also very important to mention, you don't have to import everything from its a specific module. For example, Canvas is in a module called Canvas, right? And it's a module called Canvas, but you don't have to import from Pythagoras.canvas. Import Canvas. There's a module already there. It's called Prelude that brings everything into the local namespace, so that you can from Pythagoras.prelude import whatever you want to import. Everything is there. And then you do CTX as canvas scale. Scale is a scaling factor. That's very common in TikZ, for example. But you want to work, I don't know, with coordinates being from 0 to 1, I don't know, in a very tiny space, but you want to render that as something big, right? So you provide this scaling. You can also modify it as ctx.scale equals whatever. Later if you want to do that, but I don't see why you would want to do that. In TikZ, this is compiled, so there's a flag in tech, and well, in TikZ in particular, when you create a text picture, that is scale equals whatever. So it compiles directly to that. It doesn't have any more functionality, but I mean it's mostly for SVG. So we're gonna go over this example, just drawing a very simple circle, a very regular circle, right? So first you import it, and then so we instantiated, providing its Cartesian coordinates and its radius. So something you may wanna look at the documentation for that, or if you have, the best way to use Pythagoras, or in general anything related to Python, right, is with you have your VS Code or NeoVim or whatever you have with your language server protocol, and you can see the doc string and the documentation, everything how it works. Especially Pythagoras provides all the typing for you, because I like static typing, so you can see what kind of arguments it takes all the time. So for example, you can see, so if you hover, so you write a circle instead of a circle, it will tell you that it expects a float for two floats for its x and y coordinates, and a float for its radius, right? So that's static typing, and it's very helpful, at least from my point of view. You don't have to respect that because it's Python, it's dynamically typed, but it makes you understand the type annotations, what the library is expecting. So then what you do, with any P object, what you do is you give it you can also assign it, give it a rendering priority. It's called CORD for set ordering. Doesn't have a set buffer, doesn't have a depth in and of itself, but it's a good way to name or to interpret to visualize it mentally how this works, how things are placed on screen. That's optional. You don't have to put it by default. It's zero. It's a default that has been already initialized for your in P objects. And then what you do is ctx.add circle or whatever object you have. In this case, it's a circle because this is an example. And so here's the thing. So in the left, I'm going to put the code, and the right is going to be the compile thing. And here you see from Pythagoras prelude, when for this canvas and circle. I create ctx meaning the canvas, and then make a circle with coordinate located at 0, 0 with a radius 2. And then I do ctx.add circle. And at the end, I print the TikZ figure of the thing. It's a very small one because, I mean, it's a circle, but here it is. It works perfectly fine. You can also, well, I mean, you can draw more complicated stuff. And there's instead of doing add, you can do add many. You will see, I mean, add many just adds a bunch of stuff. It takes an iterable, so something that a list of elements or a list or a tuple or whatever, a collection of p objects, and add them all to the canvas. It's called add many because we will see later that you can style your things, but using add many, they will all have the same style. So it's I mean, you perform particular for prelude. What we're gonna import now is a canvas, a circle. It's a canvas circle as before, and a path and a polygon. A path is a simple collection of points. So a path, I mean, the collection of points that are gonna be joined by lines. And then a polygon is a closed collection. It's useful because it provides a polygon the regular function. Constructor is our constructor. That what it does is create a regular polygon with the 2 and the -1 here. What they provide is the x and y coordinates. 1.5 is the radius, and 7 is the number of sides. So altogether, what you get is this, right? It's a simple scene to showcase some of the fundamental objects that you can use in Pythagoras. You also have arrows and angles. You can represent vectors, angles. That's I mean, any styling library should provide those. And here they are. I mean, here's an example using import angle, arrow, and canvas, and then we make this. The origin is gonna be 0, 0. A is gonna be 1.5, and then B is gonna be 0.25, 1. However, yeah, this is the arrow angle. Notice that I haven't put the print ctx dot text. That's because it didn't fit in the screen, so it went to the other side and it looked horrible. But you have to do it. Okay, you have to do it. You have to always. I mean, what it's doing here is constructing the canvas, and then you have to extract the compile thing. I mean, TikZ or SVG. What it does is to compile everything. So if you don't call it, nothing's gonna happen. Oops, there it is. I mean, 2 arrows and the angle formatted. Something that I think it's very nice because angles in TikZ, as far as I know, it's drawing arcs, and arcs work very weirdly. There's not like a way to, I don't know, get 3 points as you would do when you're doing geometry. You get 3 points and using the right hand rule to draw the angle between them, right? The angle they form. So I wanted something to taking those 3 points and a radius because of course you want to make it smaller or larger, so that it generates the angle from the 3 points instead of having to do weird math or weird stuff. In this case, from A to B, passing through O, it's the angle AOB, and it has 0.2 because that's its radius, but that's about it. And also you can do parametric functions. I mean, this is spiral, classic spiral, t cos t, t sine t, uh, time ranging from 0. So what you do for a parametric function is, well, we import sine, cos, and pi for math, and parametric from Pythagoras. The parametric function, the way it works is you pass a lambda. So a lambda will be a callable, anything that you can call a function that returns a point for each time. So given a time, it gives you a point. That's what a parametric function will do in this case. And then you pass two arguments being the start and the end of the time domain in this case. So it's 0, and in this case 17 pi or 16, so it's a little bit more than pi, a little bit of 180 degrees. And also you can provide a delta t. So how much do you want your t to increase? By default, it's set to 0 and then initialized as whatever the length is divided by 100. So it's split into 100 different pieces. That makes your text horribly large. Same for your SVG, but it looks sharp as you can see now. Oops, I hadn't shown it. It looks really sharp, but you can change it. You can put whatever else you want. Uh, so yeah, you can. That's how a parametric function works. There's also a similar thing. I'll explain it later. There are more other functionalities that I will cover. I will not cover in this presentation, and maybe I will do another video explaining them. So now we're going to go into the how to style and how to give any how to give colors, opacities, etc. How to do that in Pythagoras. So first we have PO properties, right? If P objects have PO properties, Pythagoras object property, uh, it's basically, I mean, there are attributes that are called PO properties, and it's something that can be rendered into SVG or TikZ, but as a quality, as something. Like a key value pair in SVG or in TikZ as an attribute, whatever. That's what a property is. I mean, it's very intuitive. You don't have to think about it much. You can. So first of all, we're gonna get rid of this. I'm gonna tell you this, and then we can move on. There's a two custom style. I mean, custom properties that are included in the styles. Custom style and custom property, which are, for example, if you want to include something that is very specific from TikZ or from SVG, you can do it that way. But that's not good. That's not the way to do it, because this is not portable at all. And the way to, I mean, the intention of Pythagoras, of the package, is to be as portable as possible, so that you can make your figure in the library in Python, and then comfortably export it to both SVG and TikZ, so that you can have your LaTeX document and also your HTML file with your web page with the figure. So this is not portable at all. I mean, if you put fill none in SVG, then TikZ is gonna say, what are you doing here? When you try to export it, it will export, but it will not do anything sensible, right? Uh, so yeah, we now we can work with colors. So it has an RGB color class implemented. It's a very simple thing to add a class. So and it's really nice because, well, first of all, there are many blue, green, and all these normal colors. SVG colors mostly are already built in, so that you can do from Pythagoras .prelude import like blue or gold or magenta or cyan or whatever. Just get it straight out of it instead of having to look it up. Most of them are already there, the most common ones. But don't try to look at, I don't know, very specific shade of gray, because that may not be there. Again, if you make a pull request, I'll gladly include it. But as of now, it's not my priority. And it has overloads. You will see that's a very common trend in Pythagoras. It overloads classes. I like operator overloading, so that you can add, subtract, multiply, and divide colors. Well, not divide them component wise, like, not divide two colors, but you can divide by two, so that you can half the brightness of a color, right? Or multiply to make it more bright. So that's it. Combining them is very straightforward. If you want to take the average between two colors, you want to mix it that way. What you do is you add the two colors and divide it by two, as you would do with anything else, or there between three or four or whatever. Uh, so you have fill, stroke. Those are the simple ones. Fill. What I mean, those are simple, very simple properties. Probably the only ones you're gonna work with, because I don't know. I don't see many other use cases, but there's more. There's more. Fill, what it does is, I mean, you have a closed shape, it will fill it. Um, it doesn't know much more to explain. And stroke, it puts the color of the boundary of the contour of the figure. It doesn't have to be a close one. I mean, it can be a vector, for example, an arrow that you want it to be green, so that you put the stroke green. Here's an example. What I do is, well, I was talking about arrows. Here's an example using arrows. We are going to use the colors gold and red. We're going to make an arrow color gold, another red, and so arrow class, canvas class, and we import stroke and line width. I mean, line width is pretty self-explanatory, so I'm not going to go over it, but I mean, it's for the width of the line. stroke again. So we make an arrow pointing from 0, 0 to 2, 0. Another one pointing from 0, 0 to 0, 2. So one is like the I hat and j hat vectors. Um, this one's gonna be gold, color gold, with a line with a 4. For the units, I believe it's points. I'm not really sure. No, actually, I think it's picas, but it's in the documentation. And this one, if it doesn't have anything, doesn't specify anything, so it's whatever TikZ does by default. And you get this. I mean, this is 2 arrows, whatever it's exactly what you specified. Now, you can also change your opacities. So you have 3 different types of opacities because while doing this, I saw that both TikZ and SVG support for changing the opacity only of the contour, only of the filling, or of both things. They're called stroke, fill, or nothing opacity. But nothing opacity by itself. Just change it all. Stroke just for stroke and fill for fill. And they range from 0 to 1. So 1 is completely opaque, and 0 is completely invisible. So there's an example. This is 2 polygons, regular polygon. This is a square and a heptagon. Um, one with fill opacity of 0.6 and the other one 0.35. You get these 2 shapes overlapping. So the cool thing is that you can see the square which is behind the heptagon, and it looks like this. And yeah, I mean, now we're gonna go into the computations, how to do operations in Pythagoras. Again, the magic of Python. What is the reason you want to use Python? Because with Python you can intertwine, you can mix the computations and the graphics, so that you don't have to separate them both. That's why, I don't know, Jupyter Notebook exists. Um, so Pythagoras has some built-in tools. I'm working on it, on improving it for doing geometry with code. First, you have vectors. Vectors are like the masterpiece here, the most important object for doing operations. You work with Cartesian coordinates, and so it has overloads almost everything you can imagine. It adds, subtract. You can make dot products, inner products, also. Cross products, which are in this case are put with a XOR operation, the hat basically, because it looks like the wedge product. It's not. I know the cross product and the wedge product are not the same, but they are very alike in the sense that, I mean, the cross product and the wedge product, they're pretty much the same thing. You can also rotate vectors with a right shift, normalize them with a method I'll show right now, and even check if 2 vectors are parallel. So this code here, so what you do is create 2 vectors. You have also some different constructors. Most of it is in documentation if you want to look at the specific details, but you can construct a vector from 2 points and also from polar coordinates. Go v1, 1, 2, and then another one is going to go from 2, 0, 2, 0, 1. So in the end, that vector is going to be 1. No, I mean, negative 2, 1. So it's going to be perpendicular, right? So when you take the the dot product, you're going to get 0. And now when we take the perpendicular of V2 is going to be the span of V1. So when we check that they are perpendicular, parallel, sorry, we do V2 dot perp. Is it parallel to V1? And it has to be true. I mean, there's an assert here, so if that this would not run if these 2 tests failed. In the end, I just add the 2 and then print the unitary so that the vector normal is have norm 1. Then finally, there's the line class, which is for drawing lines that span throughout the entire canvas, from beginning to end, to cover as much as they can. It overloads the ampersand operator for bitwise hand, basically, but it's for taking intersection. And you can give it to a circle or a line, and you'll find the points where intersect. Or maybe if it's 2 lines, and the 2 lines are concurrent, so they are the same, it will return an instance of a line. And if the 2 lines are, for example, they're parallel, but they share no points, then in that case, I mean, it will return none because there's no intersection, nothing to form an intersection. Same for the for a circle. Right now, it only there's only implemented for lines and circles. We'll be working on that soon. That hopefully changes by version 0.4.0 by the time you, well, no, you're watching this, but hopefully in the future, when you check it's probably fixed. Not fixed, but improved. What else is there? So I have a 3D render. There's also serial render implemented. It's Pythagoras.R3. Again, you can use it, access it through to the Prelude as you would do any other thing in the library. But it's Pythagoras.R3, and you have a 3D render. It's another whole thing. I may make a video on that. Uh, I don't know if I'll make it. Again, I'm lazy. And we're also working on making like some triangle geometry. There's also already implemented a triangle class, and I mean to manipulate paracentric coordinates, trilinear coordinates, and all that sort of stuff, right? You want to do with when doing triangle geometry. So I also make it for making figures in my blog. So you can check out my blog if you want. It's about nerd stuff. But I mean, I use MK Docs as of now for making the for building everything. So and it's a plugin made for specifically for MK Docs. So I may make it public sometime soon. I don't know. Well, it's already public. I mean, in my website, in the GitHub page of my website, but it's not something very formal, right? And do I mean, the rest we'll fill in the details later. So we do canvas, and we can provide the scale. So for example, let's say 10. Because we're gonna export this to SVG, let's do 50. Uh, so we first gonna add the circle as we just saw. Uh, so we do circle. Oops. Okay, 0, 0, and a radius of 10, for example. So oops, and then at the end we do ctx dot svg compile to svg. And so we do Python example, and we get this. We can pipe it into figure.svg, and we can see the example right now. Here it is. Perhaps I made it a little too big, but the point is pretty clear. You can make circles with Pythagoras. Hooray! For an example, I'm just gonna show you the code that it is. This is the example from the very first page. It is just so we import the necessary stuff here, and then we make two vectors and their addition, and we provide the stroke and the fill, and also this style called dashed if you want dashed things, dash lines. So we can compile this as it's called arrows in this case into arrows.svg. In fact, actually, I think it's put as text, so I should change this, and now we can see it. And you will see that this is invisible. I mean, you can barely see this because the scaling is adapted uh, for text. I mean, there's no scaling at all. And very small dimensions, so I can put the scaling to 50, compile it again, and see that there it goes.